Now you own the Eddycon C eddy current flow detector. The instrument ensures the reliable eddy current testing. Let's see how should look here purchased at the time you have received it. The flow detector is delivered in a bag. The instrument delivery set should obviously include the following items inside the bag. Electronic unit of the flow detector Eddycon C. The instrument is delivered with clip-on handles for the convenient hold on the operator hand. The charger is used for connecting the instrument to the electricity mains and for charging the removable battery. Two cables for connecting the ECP that is included to the basic delivery set to the flow detector. The Enterprise calibration block 235308 is used for setting up the parameters of ECP and flow detector pair. In the Ziploc bag you should find the EC probe that is included to the basic delivery set, the ECP of SS340K09DA0 type in an additional housing for the tip protector, USB mini USB cable for connecting the flow detector to the PC, operating manual for eddy current flow detector Eddycon C, registration certificate for calibration block 2353.08. Please be sure to read these documents, they contain the important information. Compact disc for installing the specially configured software that allows you to transfer data from the device to the PC for further processing. Charger adapters allow to connect the charger to sockets that support different standards. Thus we have checked the delivery set. Let's look closer at electronic unit of Eddycon C and functional capabilities. The left side panel includes the headphone connector with inbuilt microphone, the charger connector, power key. Press this key to switch on/off the flow detector. The rear panel of the flow detector includes the nameplate with the identification data of the flow detector, serial number, name, manufacturer data, and etc. Ethernet port for connecting a communication cable to PC. USB port for connecting the portable USB drive. The right side panel includes parametric eddy current probe connector, ECP and router scanner connector, encoder connector, tap of a battery compartment, To switch on the flood detector, press and hold the power key until the sound and light signals are appeared. The front flood detector panel includes F1 key in the main mode is used as balancing in other modes according to the mode selected. F2 key in the main mode switches the form of signal display on the instrument screen. In other mode is used according to the mode selected. F3 key in the main mode is used as erase in other modes according to the mode selected. Key for moving up through the flood detector menu. Key for moving down through the flood detector menu. Key for changing the step of a selected parameter. Key for increasing the value of selected parameter or for selecting its possible values. Key for decreasing the value of a selected parameter or for selecting its possible values. Key for confirming the entered value, Enter key. Key for the quick access to Settings menu. Key for the quick access to Test menu. Key for the quick access to Archive, loading, saving the testing results and settings. Key for returning to the previous menu level. Cancels the selection. Key for the quick access to calibration menu. Key for the quick access to the view mode for testing results review. Key for automatic setup of the parametric eddy current probe. Key for changing the frequency. Automatically puts a displayed signal from lead-off in horizontal position. Setup and calibration of differential reflection type EC probe. Differential type probes are used for testing the conducting materials with a flat surface for the presence of surface and subsurface defects. Connect the EC probe to the flood detector using the reflection type cable. Make sure that red marks on the mating connector parts have been matched. The marks ensure the correct cable position during the connection. Different tasks require the application of EC probes with different diameter of operating surface. Differential EC probes are delivered in protective housing to be protected from mechanical damages. The housing of EC probe can be dismounted by unscrewing the dismountable parts of the housing. The EC probe has its designation on the side surface where the operating frequency and probe diameter are indicated. Wearproof protector is located in the bottom side of the housing. When assembling the protecting housing of EC probe, make sure the mark on the end surface of ECP has been matched with the groove on the upper end of the protective housing. Switch on the instrument by pressing and holding the power key until the sound signal is appeared. After the instrument was switched on, select the language. Set up the operating frequency of EC probe that is specified on the housing. In a relevant menu item, select the type of a connected ECP, in our case, reflection type probe. Next step is to set up the preliminary and main gain for the receiving circuit. Switch off the filter. Set the alarm time circuit and set up its parameters. Set up the position of 0 point of signals. The most suitable in our case is the center position. Try change the type of a screen marking and activate the coordinate axis. Change the displaying scale in Options menu. Set up the value for generator voltage. Later we can change this value depending on the signal amplitude. Place the EC probe at a flow-free area of calibration block. Perform the balancing by holding the probe in a static position. Scan the block surface and, in a complex plane, analyze the signals received from the artificial defect. If the level of received signals is low, change the gain and voltage values. To plot the curve for depth estimation, enter the calibration mode. To plot the calibration curve, use the signals received during the scanning of the block with the known parameters of artificial defects, in this case the amplitude. When plotting the calibration curve on the basis of signals received from the block, mark these norms and select When moving the position of a measurement cursor, find the signals received for the given block. For 2353.08 calibration block, there should be 5 signals. By changing the width and position parameters of a measurement cursor, highlight the signal area from the first minimal defect and add the curve point. The added curve point shall be appeared in a table in the bottom left corner of the screen. To finish the calibration, perform the similar steps with other signals. The death of artificial defect is set up automatically when the mode of acquiring the curve by block is active. Otherwise, they should be set up. After acquiring all curve points, move to the test mode. Place the EC probe at the fall-free area of a testing object, in this case the calibration block. Perform the cleansing when the EC probe is in the static position. Perform the scanning of a testing object. Move to the View mode for testing results review. Move the measurement gate to the area where the signals are received from defects. Set up the width and position of a cursor within the signal and estimate the depth. The defect depth is displayed in the bottom part of the instrument screen. Estimate the depth of all other defects in a testing object. If required, save the created flaw detector setup. Assign the original name to the saved setup for further convenient use. The flaw detector is set up and ready for the testing. Enter the memory menu and save the testing results. The saved results can be reviewed on the flaw detector or PC. Setting up the parameters of Eddycon absolute type probe. Absolute probes are used for detecting the subsurface defects during the testing. Use the Llama 00 cable to connect the EC probe to the flaw detector. The advantage of this probe is the capability to carry out the testing of spherical and other surfaces with a complex profile and limited access. After the probe was connected, switch on the instrument by pressing and holding the power key until the sound signal is appeared. Wait for the operation system to be loaded. Now start the setting up procedure. Select the type of a connected probe single. Set up the probe frequency. Its value is indicated on a probe housing. Set up the values of a preamplifier and main gain. Set up the vertical and horizontal gain to 0. Switch off the filter. Set up the position for the 0 point of a complex plane, the right lower corner. While holding the EC probe in the air, press the key of auto capacitor feed. Wait for the inscription to be appeared. Place the EC probe at a flow-free surface of a block perpendicular to the surface and perform the balancing. When changing the inclination angle of the probe to the vertical scale, we shall achieve the signals from the probe distribution in a complex plane. Press the auto lift key that automatically puts the displayed signal from a lift off into the horizontal complex plane. Perform the scanning of a block surface. Analyze the position of signals received from the probe distributions and defects on the complex plane. The signals received from the probe distributions shall be located in a horizontal complex and friendly signals in a vertical. Clear the flow detector screen, then set up the filter averaging and its parameters. Set up the linear type of alarm and set up its parameters. In this case, we set up the height. Place the EC probe at a flow-free area of a block and perform the balancing. To improve the visualization display of signals received from defect-friendly signals, increase the horizontal gain. Perform the confirming balancing and scanning of a block surface. Change the inclination angle of a probe to make sure that the signal from the probe distribution has not crossed the alarm. The flow detector is ready for operation with an absolute probe. Rotary EC probes are used for defects detection in test with holes made of aluminum alloys, ferromagnetic and austenitic steel. EC probes are driven by the rotary scanner, which is connected to the flow detector through the specialized cable. The EC probe is inserted into the scanner connector. When inserting the EC probe, make sure that the marks on the probe housing and rotary scanner have been matched. When inserting, press the probe until tight. To stop the probe rotation, press the button from the side face of scanner. To operate the rotary scanner, include it into the relevant menu. In the appeared dialog window, select the type of a used rotary scanner. The type of a device is indicated on its case. Set up the probe operating frequency. Ultra-conservative LLC probes operate in a range from 500 kHz to 2 MHz. Set up the main and preamplifier gain. Set up the generator voltage. Input the EC probe into the calibration hole of a block perpendicular to the surface. Perform the balancing at known flow-free area of a hole without starting the probe rotation. Start the EC probe rotation by pressing the button on the side face of a scanner. Perform the scanning of a hole with an artificial defect of a calibration block by moving the EC probe along the opening surface. If required, correct the values of a generator gain and voltage. As the signals that we can observe on the screen during the scanning are not meaningful, switch on the filter. Select the bandpass filter with a range from 200 kHz to 500 kHz and carry out the confirming scanning of a hole surface, having previously performed the balancing. In our case, we should increase the gain until the signal crosses the alarm level. Every time you change the gain or generator voltage, it is needed to perform the confirming balancing at a flow-free area of a block. In this calibration block, the artificial defect is located in the upper part of a hole. When moving the EC probe to the upper part of a block, we can observe how the signal changes in a complex plane. If required, change the speed value for the probe rotation in a relevant menu item. Perform the control scanning of a block cavity. During these steps, we have set up the flow detector for operation with the rotary probe. Save the current setup into the flow detector memory, having assigned the unique name. To assign the name for the setup, use the letter key of the flow detector. Weld-type EC probes are used for testing the surface defects of welded joints. Use the bridge-type cable to connect the EC probe to the flow detector. When connecting the cable, the special attention should be paid on marks to be matched. Make sure the marks on cable connectors, EC probe housing, and instrument case have been matched. In the relevant menu item of the flow detector, select the type of EC probe, in our case, bridge type. Set up the gain vertical and horizontal values to 0 dB. Set up the frequency of EC probe that coincides with the value that is indicated on the probe housing. Set up the values of a preamplifier and main gain of a receiving circuit. Set up the value of generator voltage. Place the EC probe at a flow-free area of a block surface and perform the balancing by holding the EC probe perpendicular to the scanning surface. Perform the scanning along all artificial defects. To improve the visualization of signals received from defects, change the parameters of preamplifier and main gain of a receiving circuit. Switch on the filtering. In our case, select the low frequency filter and its parameters. Set up the 0 point on a complex plane in the bottom part of a screen. This ensures the active area of a screen to be used optimally. Also, it is possible to set up manually the 0-point coordinates vertically and horizontally that is the most suitable in this case. After the parameters were corrected, once again place the EC probe at a flow-free area of a block and perform the balancing. Carry out the scanning along the block surface and analyze the signals in a complex plane. We can observe that friendly signals go beyond the active area of a screen. To eliminate this, you should set up the phase value at which the friendly signals will be located in an active area of a screen. After the phase was set up, perform the confirming, balancing and scanning. When analyzing the signals, we can observe that they are fully located in an active area of a flaw detector screen. Then select the alarm. In this case, the most suitable variant is the linear type of alarm. To determine the alarm parameters, perform the confirming, balancing and scanning of calibration block. In this case, we are increasing the gain parameter until the signal crosses the alarm threshold. Perform the confirming, balancing and scanning to check the setup parameters. The setup was successful and the flaw detector is ready for operation. Due to the capability to create the mix of two frequencies, it is possible to suppress the interfering factors and decrease their influence on a test result. Select the type of a connected probe. In this case, it will be reflection type probe. Enter the settings menu and switch on the double frequency mode of flaw detector operation. To set up the double frequency mode, click the marker in a relative menu item. Return to the test mode. Now we are located on the first page of frequency setup, that is assigned with the digit 1 located near the 0 point on a complex plane. Set up the value for the first frequency. Change the preamplifier and main gain. Also, if required, change the value of a generator voltage. Select the filter type, in our case, averaging, and set up the number of averages. Place the EC probe at a flow-free area of the calibration block and by holding it in a static position, perform the balancing. Carry out the scanning along the surface of a calibration block and analyze the received signals from artificial defects in a complex plane. Set up the acceptance level by one of artificial defects by changing the parameter of circle alarm. After setting up the acceptance level, carry out the control scanning of a block surface. All parameters set up correctly. Go to the second page of a frequency setup. Now we are located on the second page of frequency setup, that is assigned with the digit 2 located near the 0 point. Set up the value for the second frequency and values for the preamplifier and the main gain of a receiving circuit. Set up the value of a generator voltage. Select the filter type, in this case averaging. Set up the number of averages. Select the type of alarm, circle, and set up its perimeter, radius. Place the EC probe at a flow-free area of a block and by holding it in a static position, perform the balancing. Carry out the scanning along the block surface and analyze the signals received from artificial defects in a complex plane. To improve the display visualization, the signals received for two frequencies are to be placed over the circle. Change the phase on a second page. Place the EC probe at a block and perform the confirming, balancing and scanning of a block surface. If required, repeat the procedure. Go to the third page of a frequency setup. Here the signals of the first and second frequency and of a mix of two frequencies are displayed. Place all overlapping signals on the active area of a complex plane. To perform these tasks, change all center coordinates. Select the type of alarm for the area of frequency mix and set up the parameters. The user is always capable to flip the pages for frequency setup and change the parameters. Having changed the parameters, return to the page of a frequency mix. Place the probe at a flow-free area of the block and by holding it in a static position, perform the balancing. Carry out the scanning along the surface of a calibration block. To improve the signal visibility, displays the complex plane center of frequencies mix number 3. Carry out the control scanning of a block surface. The flow detector allows to change the type of frequency mix. Accordingly, depending on a mix type of the frequency mix will be changed. This change can be observed in a complex plane.